Section 20 of Gray's Anatomy Part 2. This is LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Logan McCammon. Anatomy of the Human Body, Part 2, by Henry Gray. Talocrural articulation, or ankle joint. The ankle joint is a gigglymus, or hinge joint. The structures entering into its formation are the lower end of the tibia and its malleolus, the malleolus of the fibula, and the transverse ligament, which together form a mortise for the reception of the upper convex surface of the talus and its medial and lateral facets. The bones are connected by the following ligaments: the articular capsule, the anterior talofibular, the deltoid, the posterior talofibular, and the calcaneofibular. The articular capsule, capsula articularis, capsular ligament. The articular capsule surrounds the joints and is attached above to the borders of the articular surfaces of the tibia and malleoli, and below to the talus around its upper articular surface. The anterior part of the capsule, anterior ligament, is a broad, thin, membranous layer attached above to the anterior margin of the lower end of the tibia, below to the talus, in front of its superior articular surface. It is in relation in front with the extensor tendons of the toes, the tendons of the tibialis anterior and peroneus tertius, and the anterior tibial vessels and deep peroneal nerve. The posterior part of the capsule, posterior ligament, is very thin and consists principally of transverse fibers. It is attached above to the margin of articular surface of the tibia, blending with the transverse ligament below to the talus behind its superior articular facet. Laterally it is somewhat thickened and is attached to the hollow on the medial surface of the lateral malleolus. The deltoid ligament, ligamentum deltoideum, internal lateral ligament. The deltoid ligament is a strong, flat, triangular band attached above to the apex and anterior and posterior borders of the medial malleolus. It consists of two sets of fibers, superficial and deep. Of the superficial fibers, the most anterior, tibio-navicular, pass forward to be inserted into the tuberosity of the navicular bone, and immediately behind this they blend with the medial margin of the plantar calcaneonavicular ligament. The middle, calcaneotibial, descend almost perpendicular to be inserted into the hole of the sustentaculum tali of the calcaneus. The posterior fibers, posterior talotibial, pass backward and lateralward to be attached to the inner side of the talus and to the prominent tubercle on its posterior surface, medial to the groove for the tendon of the flexor hallucis longus. The deep fibers, anterior talotibial, are attached above to the tip of the medial malleolus, and below to the medial surface of the talus. The deltoid ligament is covered by the tendons of the tibialis posterior and flexor digitorum longus. The anterior and posterior taliofibular and calcaneofibular ligaments were formerly described as the three fasciculi of the external lateral ligament of the ankle joint. The anterior talofibular ligament, ligamentum talofibular anterius. The anterior talofibular ligament, the shortest of the three, passes from the anterior margin of the fibular malleolus forward and medially to the talus, in front of its lateral articular facet. The posterior talofibular ligament, ligamentum talofibular posterius. The posterior talofibular ligament, the strongest and most deeply seated, runs almost horizontally from the depression at the medial and back part of the fibular malleolus to a prominent tubercle on the posterior surface of the talus, immediately lateral to the groove for the tendon of the flexor hallucis longus. The calcaneofibular ligament, ligamentum calcaneofibular. The calcaneofibular ligament, the longest of the three, is a narrow rounded cord running from the apex of the fibular malleolus downward and slightly backward to a tubercle on the lateral surface of the calcaneus. It is covered by the tendons of the peroneus longus and brevis. Synovial membrane. The synovial membrane invests the deep surfaces of the ligaments and sends a small process upward between the lower ends of the tibia and fibula. Relations. The tendons, vessels, and nerves in connection with the joint are, in front from the medial side, the tibialis anterior, extensor hallucis proprius, anterior tibial vessels, deep peroneal nerve, extensor digitorum longus, and peroneus tertius, behind, from the medial side, the tibialis posterior, flexor digitorum longus, posterior tibial vessels, tibial nerve, flexor hallucis longus, and in the groove behind the fibular malleolus, the tendons of the peroneal longus and brevis. The arteries supplying the joint are derived from the malleolar branches of the anterior tibial and the peroneal. The nerves are derived from the deep peroneal and tibial. Movements. When the body is in the erect position, the foot is at a right angle to the leg. The movements of the joint are those of dorsiflexion and extension. Dorsiflexion consists in the approximation of the dorsum of the foot to the front of the leg, while in extension the heel is drawn up and the toes pointed downward. The range of movement varies in different individuals from about 50 degrees to 90 degrees. The transverse axis about which movement takes place is slightly oblique. The malleoli tightly embrace the talus in all positions of the joint, so that any slight degree of side-to-side movement which may exist is simply due to stretching of the ligaments of the talofibular syndesmosis and slight bending of the body of the fibula. The superior articular surface of the talus is broader in front than behind. In dorsiflexion, therefore, greater space is required between the two malleoli. This is obtained by a slight outward rotatory movement of the lower end of the fibula and a stretching of the ligaments of the syndesmosis. This lateral movement is facilitated by a slight gliding of the tibiofibular articulation and possibly also by the bending of the body of the fibula. Of the ligaments the deltoid is of very great power, so much so that it usually resists a force which fractures the process of the bone to which it is attached. Its middle portion, together with the calcaneofibular ligament, binds the bone of the leg firmly to the foot, and resists displacement in every direction. Its anterior and posterior fibers limit extension and flexion in the foot respectively, and the anterior fibers also limit abduction. The posterior talofibular ligament assists the calcaneofibular in resisting the displacement of the foot backward, and deepens the cavity for the reception of the talus. The anterior talofibular is a security against the displacement of the foot forward, and limits extension of the joint. The movements of inversion and eversion of the foot, together with the minute changes in form by which it is applied to the ground or takes hold of an object in climbing, etc., are mainly effected in the tarsal joints, the joint which enjoys the greatest amount of motion being that between the talus and calcaneus behind and the navicular and cuboid in front. That is often called the transverse tarsal joint, and it can, with the subordinate joints of the tarsus, replace the ankle joint in a great measure when the latter has become ankylosed. Extension of the foot upon the tibia and fibula is produced by the gastrocnemius, soleus, plantaris, tibialis posterior, peroneal longus and brevis, flexor digitorum longus, and flexor hallucis longus, dorsiflexion by the tibialis anterior, peroneus tertius, extensor digitorum longus, and extensor hallucis proprius. Note 74. The student must bear in mind that the extensor digitorum longus and extensor hallucis proprius are extensors of the toes, but flexors of the ankle, and that flexor digitorum longus and flexor hallucis longus are flexors of the toes, but extensors of the ankle. End of section 20. Recording by Logan McCammon.